Hi, welcome to tight bound running time calculation, that is average time calculation for given cubic function f of n equal to 4n cube plus 5n plus 8. We can say show that 4n cube plus 5n plus 8 equal to big theta of n. Find c1, c2, n0. Here c1, c2 are constant, always should be positive number. Initial input size also should be positive number. Uh, to compute the tighter bound, we should have the given condition 0 less than or equal to c1 into g of n less than or equal to f of n less than or equal to c2 into g of n. So that's the condition given here, right, from the figure. So now we are substituting the given cubic function in the place of f of n. So we are substituting 4n cube plus 5n plus 8. Here the dominating term is n cube. So coefficient is 4n cube 4. So in the left side it should be equivalent to this f of n or less than. Okay, so previous term, I mean smaller term is 3n cube and 2n cube, etc. So here we are taking the equivalent term 4n cube in the left hand side, because the equivalent term also can be considered here. Equivalent term also can be considered c1 into g of n less than or equal to f of n. Like that in the RHS, c2 into g of n. So here the f of n less than or equal to c2 into g of n. So here dominating term is n cube, and we will take coefficient of all these terminologies 4, 5, 8. Then we will take dominating term is here with the degree 3 n cube. So we are taking the n cube. Why we are taking the n cube? In the sense, you see, this is greater. Okay, right hand side is here f of n is always less than or equal to c2 into g of n. So f of n is here we are taking the dominating term 4n cube. So 4n cube in the RHS, it may be a 4n cube because equivalent 4n cube or greater value 5n cube, 6n cube, etc. infinity, right? So here when we are taking the equivalent term, we will get a different c2. We are taking the this, when you're calculating this by taking the coefficient of n, this is the constant. So what is the value? 17n cube. 17n cube also in this range, in this range. So that's why we are taking the values which are having some coefficient of this remaining terms. Okay, so now when you are calculating this is c1 into g of n, f of n less than or equal to c2 into g of n. So from this step we can identify c1 equal to 4, c2 equal to 17. Now we should check this condition is true or not. So initially we will take positive number n0 greater than 0. So we will take 1. So n equal to 1. So 4 into 1 4 less than or equal to 4 plus 5 plus 8 17 less than or equal to 17 into 1 17. So this condition is true for given n0 equal to 1, n equal to 1. Like that when you are substituting the n equal to 2 also it will be true. So from this step we can finalize for all n greater than or equal to 1, this given condition is true for function f of n. So we can finalize f of n equal to theta into g of n equal to theta of n for identified c1 4 and c2 equal to 17 for initial input size 1. Like that we will get infinity number of terms, because we are having, you see, remaining terms 3n cube also there, 2n cube also there. So when you are substituting here 3n cube, here in this side you may substitute a different 6n cube or 18n cube or 20n cube. So there you will get different c1 and c2, also n0. Thanks for watching.